Applications and limitations of the method of dimensional analysis. Now, some of the applications of dimensional analysis. What are the applications? One is converting a physical quantity from one system of unit to another system. You can convert a physical quantity from one system, that is, there are various systems, that is CGS system, FPS system, MKS system, SI system, like that, various systems. So we can convert one system of unit, that is from CGS system to SI system, or from SI system to FES system. Like that, you can convert a physical quantity from one system of unit to another system of unit. Second thing, we can check the dimensional correctness of a given equation. If a equation is given, you can find it out whether the equation is correct or not using the method of what? Dimensions. The third one is establishing relationship among various physical quantities. Suppose there are three physical quantities are there. If you want to find out a formula among those three physical quantities, then can use the dimensional method to find out the relationship between the physical quantities. Okay, so these are the three uses of what? Dimensional analysis. So now we can go one by one with examples. Now, to convert a physical quantity from one system of unit to another system of unit. Okay, now this is based on the fact that the product of numerical values and the corresponding unit. That is, n is called as the numerical value and u is the corresponding unit. So we can write n into u is a constant. The formula which we are going to write it here is n into u is a constant. Now this can be written as n1 u1 is equal to n2 u2, where n1 and n2 are the system of numerical values of the units, and u1 or u2 are the system of units. Okay. Now we are going to take a physical quantity which is having dimension a and mass in mass and b in length and c in time. So we can write it as m raised to a, l raised to b and t raised to c. Okay. In one system we are writing it as m1 l1 t1, and another system we are writing it as m2 l2 t2. So we can write n1 is the numerical value of the first system, and the unit can be written as m1 raised to a, l1 raised to b and t1 raised to c. And n2 is the numerical value of the second system, and we can write the unit as m2 raised to a, l2 raised to b and t2 raised to c. Okay. Now using this relation, we can convert one system of unit to another system of unit. Okay. Let's see one example here. Now we are going to convert Newton into dyne. Okay. Newton is the unit of force in SI system, and dyne is the unit of force in CGS system. Okay. Now we can write the dimension of force. The dimension of force can be written as L m t raised to minus 2. So L raised to 1, m raised to 1, t raised to minus 2. Okay. Now we can write 1 Newton. 1 Newton is in SI system we are going to write. So this is the value of L. The value of L in SI system is 1 meter. The value of m in SI system is 1 kg. The value of t in SI system is 1 second. Okay. So we can write it as, for L it is 1 meter, for m it is 1 kg, and t it is 1 second raised to minus 2. Here and all it is power raised to 1. And we can write for 1 dyne. 1 dyne is L in CGS system is 1 centimeter. M in CGS system is 1 gram. Time in CGS system is 1 second. So we can write it as 1 centimeter, 1 gram and 1 second raised to minus 2. Now we are going to divide one by the other. 1 Newton by 1 dyne, which is equal to 1 meter by 1 centimeter. Okay. 1 kg by 1 gram. 1 second by 1 second raised to minus 2. Now we are going to convert the meter into centimeter. So it is 1000 centimeter, 100 centimeter. 100 centimeter by 1 centimeter. 1 kg into gram, 1000 gram by 1 gram. 1 second by 1 second. Now here the centimeter and the centimeter will get what? Cancelled. Okay. And what are the other things which get cancelled here is, here this and this will get cancelled. We can cancel it easily. And the gram and gram will get cancelled. And this two terms will get what cancelled. So when you cancel it, what you get it 1 second and 1 second. That is 1 raised to minus 2. That is nothing but what? 1. Now we can write it as 100 into 1000. 100 into 1000 is what? 10 raised to 5. So what is the value of 1 Newton? 1 Newton by 1 dyne is 10 raised to 5. 1 Newton is equal to 10 raised to 5 dyne. Okay. So we can easily what? Convert from one system of unit to another system of unit. Okay. Now, the second thing is to check the correctness of the given equation. Check the correctness of the given equation. Now you can write delta x is equal to VIT plus half AT square. This is same as that of what? This equation. S is equal to UT plus half AT square. You can write it in other way as what? S is equal to, you can write it as S is equal to UT plus half AT square. Okay. This equation and this equation are same. This equation and this equation are what? Same. Now we are writing S instead of the delta x, that is displacement L. VIT, that is VI is velocity. U is initial velocity. VI is initial velocity only. Velocity into time. Length by time. Velocity is nothing but what? Length by time. Into time. Time and time will get cancelled. So you'll get the dimension for length. Acceleration. A is acceleration. T is time square. So acceleration is length by time square into time square. So time square and time square will get cancelled. So you are getting length. Now this is having dimension L. This is having dimension L. And this is also having dimension L. All the terms in the equation are having the same dimension. So what you can say? This is dimensionally correct. We can say that is dimensionally what? Correct. Okay. Now we'll go for another example here. Let us take V is equal to U plus AT. V is your final velocity, U is your initial velocity. Okay. So the dimension for velocity is what? Length by time. So LT raised to minus 1. Initial velocity is also same. Acceleration is what? LT raised to minus 2 into time. So T raised to minus 2 plus 1. So it is T raised to minus 1. So what we can write? LT raised to minus 1 is equal to LT raised to minus 1 plus LT raised to minus 1. All the terms are having the same dimension. So what you can say? The equation is dimensionally correct. Now the third use, to establish the relationship among various physical quantities. So we are going to find out an equation. Okay, so we can write if a physical quantity Q, we are taking one physical quantity as Q, and that physical quantity is depending upon three other physical quantities. So we are writing the three other physical quantities as Q1, Q2 and Q3. So the quantity Q is depending upon the three physical quantities Q1, Q2 and Q3. So we can write Q is proportional to Q1 raised to A, Q2 raised to B and Q3 raised to C. Now this proportional sign, this one is replaced by equal to and a constant. So instead of this proportionality sign, I am writing Q is equal to K into Q1 raised to A, Q2 raised to B and Q2 raised to C, where K is called as the dimensionless constant. Okay. When the dimensional formula Q1, Q2, Q3 and are substituted according to the principle of homogeneity, the powers are equated on both the sides of the equation. Then we'll get the values of A, B and C, and when we can find it out the equation. We have to equate the, after substituting the dimensions for these physical quantities, we have to equate the powers and then we have to find out the relation. Let us see one example. We are going to find it out the time period of a simple pendulum. Okay. We are taking The time period of a simple pendulum is depending upon two physical quantities. Okay, that is acceleration and length. Okay, so I'm going to write the time period is proportional to L raised to A and G raised to B. L raised to A and G raised to B. So T is equal to, the proportionality sign is what? Replaced by equal to and a constant. So T is equal to K into L raised to A, G raised to B. Now I'm going to write the dimension of T. The dimension of T is T only. But I'm writing in terms of three quantities raised to the powers. So L raised to 0, M raised to 0 and T raised to 1. Dimension of length is L. So L raised to 1, M raised to 0, T raised to 0. Dimension of G, acceleration due to gravity, that is LT raised to minus 2. So I can write it as L raised to 1, M raised to 0, T raised to minus 2. Now I am going to substitute in this equation. For T, I am substituting as L raised to 0, M raised to 0, T raised to 1, which is equal to K into, K is not having dimension, I am writing it as K itself. L is L raised to 1, this one I am writing. M raised to 0, T raised to 0 raised to A. And G is L raised to 1, M raised to 0, T raised to minus 2 raised to B. Now I'm going to multiply this A inside. So it is L raised to A. These are all zeros. Here it is B. Here minus 2B. Okay. Now I can add the powers in the left hand side. L is having A and B as power. So I can write it as L A plus B. M is having only 0. Leave it as 0 itself. T is having 0 minus 2B. So that is minus 2B. Now I am going to equate the powers. Now what is the power of L in right hand side? A plus B. Left hand side it is 0. So I can write A plus B is equal to 0. For M, both the sides are 0. We can leave it. For T, it is minus 2B. Here it is 1. So it's minus 2B is equal to 1. So we have equated the powers. Now, minus 2B is equal to 1. So what is B? B is equal to minus 1 by 2. Okay. So substituting B is equal to minus 1 by 2, A will get it as what? 1 by 2. A will get it as what? 1 by 2. So we are getting the value as A as 1 by 2 and B as what? Minus 1 by 2. Now, I'm going to substitute here in this equation. So T is equal to K into L raised to A, L raised to half, G raised to minus half. What is L raised to half? L raised to half is root L. G raised to minus half is 1 by root G. So this can be written as T is equal to K into root of L by G. If the value of K is given in the problem, then you can substitute the value of K. Suppose if you take the value as 2 pi, then you can write it as T is equal to 2 pi into root of L by G. 2 pi into root of what? L by G. So here we are finding the relationship between the physical quantities, time, length, and acceleration due to gravity. So between these three physical quantities, we have found a relationship and we have found out the time period of the simple pendulum. So the method of dimensions is used to find out the equation of a particular physical quantity. Okay, so we have learned three uses. One is to convert one system of unit into another system. The second thing is to check the correctness of the equation. The third thing is establishing the relationship among the physical quantities. So now we have to go for the limitations of the dimensional analysis. What are the limitations of dimensional analysis? Now, dimensional constants cannot be determined by this method. We can't find out the dimensional constant by this method. Okay. Second thing is we cannot apply the equations involving exponential and trigonometrical functions. That is, exponential is e raised to x, e raised to minus 5x, like that, exponential quantities. We can't use the dimensional method. And trigonometrical functions also, sine theta, cos theta. If the equation is having thetas, okay, sine theta, cos theta, cot theta, or any functions of trigonometry, that cannot be applied. in the method of dimensions. And we can find out the relationship among the physical quantities, not more than what three physical quantities. Only for three physical quantities, if it is depend, then we can find out the equation, because we can solve only three unknown terms at a time. So it is difficult to find it out an equation for more than three physical quantities. And we can check the equation is correct or not, but we can't tell the equation is really correct or not. That is absolutely correct or not. If an equation is there, we can check the equation and say whether it is correct or not. But it is a true equation or not, we can't say that. Okay. And we can't use this method to decide whether the quantity is a vector quantity or a scalar quantity. We can't decide the quantity. Okay, so these are some of the dimensions of what? Dimensional limitations of dimensional analysis. So in this video, we have learned the uses and the limitations of what? Dimensional analysis in detail. Hope you could have understood. We'll see in the next video.